Oh, what's up, mathematicians? Justin here. I seriously can't get enough of this game. I've been flying through the levels, solving all these equations. I finished all the one-step equation levels, and I've moved up to two-step equations. Oh, here we go. Minus 8 divided by 5, W equals negative 10. Right again. Nothing can stop me now. Ooh, 3x plus 5x equals 40. I've never seen an equation like this before. But I have high scores to set, so let's figure it out together. I've been thinking about it. It's hard to tell which term to undo first because x is being multiplied by 3 and it's being multiplied by 5. And both numbers are directly attached to x. How are we supposed to get x by itself when it's in two different places at once? Any ideas? Wait a second. 3x and 5x are like terms, which means we can combine them. Maybe that'll help.
3x plus 5x is 8x. So now we have 8x equals 40. Hey, that's a one-step equation now. We solved a bunch of these. What do we do? Totally. Divide by 8 on both sides. That gets us x equals 5. Before I lock it in as my final answer, though, let's check our work. We now have two different places to substitute the solution for the variable, so we'll do that. We evaluate the left side, starting with the multiplication from left to right, and then add the two terms together. Cool, we get 40 equals 40, so our solution is correct. All right, I'm picking x equals 5. Yes! Okay, we're cruising along in this game again. It looks like sometimes we might have an extra step when we solve equations, simplifying each side of the equation. That's good to know. We'll add it to our checklist. Why don't you try the next one? 17.82 equals 9m minus 0.9m. Pause while you work. Check your work. In this equation, there are two m terms on the same side of the equal sign. So we have to simplify that side of the equation before we can isolate the variable. What do we get when we do that? Yeah, 17.82 equals 8.1m. Now we have a one-step equation left over, and we can divide both sides by 8.1 to get 2.2 equals m, or m equals 2.2. We can't forget to check our solution, though. When we substitute 2.2 for m in both places and evaluate the right side of the equation, it checks out.
All right, next level. 6 minus 11h equals negative 5h. Huh. Again, the variable is in two different places at once, so we're going to need to combine them. But what's different about this equation? The variable terms are on different sides of the equal sign. How do you think we can get these terms together on the same side? Well, the fact that they're separated by an equal sign means we can't just combine them like we did in the last two equations. If we need to get rid of a term from one side in order to combine it with a like term on the other side, we use inverse operations. It's just like when we need to get rid of one term from one side in order to isolate a variable. It helps us make sure we always keep the equation balanced. Basically, anytime we're undoing an operation in an equation or moving a term from one side to the other, we'll use inverse operations. If we're combining like terms on the same side, though, we don't use inverse operations. Do you think it matters which side we move the variable to? Technically, no, but when we solve equations, we're looking to get numbers on one side and variables on the other, so let's plan ahead and arrange our equation that way now. In this equation, would that mean undoing minus 11h to move it to the right side, or undoing negative 5h to move it to the left side?
Well, the 6 is already on the left side, so we'll keep our numbers on that side and get our variables on the right side. That means we'll use inverse operations and add 11h to both sides to be able to combine it with negative 5h. That gives us 6 equals 6h. Hey, we made it into a one-step equation. How do we finish solving it? You got it. Divide both sides by 6. H equals 1. As always, the final step is to check our work. This time, not only do we have to substitute the solution into 2 spots, but we have to evaluate the left side and the right side of the equation. It's all good though. No matter which side we start with, we'll end with negative 5 equals negative 5. Looks like we have another step to add to our checklist, combining variables onto one side. We might not have to do every step in every equation, but the checklist is helpful to make sure we don't forget anything.
New level, let's go. What is happening here? Oh, I see. 10 divided by d. We've seen equations with division before, but not like this. How is this one different from 5 equals d divided by 10? In this new equation, 10 is being split into some unknown number of equal groups, whereas in the equation like the ones we've solved before, d is being split into 10 equal groups. So then, how can we isolate d?
In equations like this, the variable is tangled up inside the division itself. There is no direct inverse operation that can get it by itself when it's stuck in the denominator. So we have to start by separating the fraction. What inverse operation will undo a fraction? Right, multiplication. So we'll multiply both sides by d. On the left, 5 times d is 5d, and on the right, multiplying by d cancels out dividing by d, and we're left just with 10. Now we have 5d equals 10. And we can solve that. Divide by 5 on both sides, and we have d equals 2. Let's check it just to be sure. Substituting 2 for d into the original equation and evaluating gives us 5 equals 5. We figured it out. It was all about using inverse operations. You've got 2 more problems here. Pause while you solve each equation and come back when you're done. Compare your work to mine. If you notice any mistakes in your work, be sure to fix them in your guided notes.
Thanks for helping me figure out these new equations and beat more levels of my game. Don't forget to finish up the guided notes and complete levels 1 through 3 of the online practice. Until next time, keep questioning, keep calculating, and remember, in some equations, you might need to combine like terms or get the variable out of the denominator before you can isolate it. See you next time.
Hey, hey.